Ever pondered the science behind the purity of monoclonal antibodies? Or how these intricate molecules are purified for use in healthcare? The answer lies in a powerful technique known as affinity chromatography. Affinity chromatography is an elegant method that hinges on the specific binding interaction between two key players: our target molecule, the monoclonal antibody, and a ligand immobilized onto a chromatography matrix. This ligand is often a molecule that binds to the monoclonal antibody with high specificity and affinity, effectively acting as a molecular magnet. Selecting the right ligand is no small feat. It requires a keen understanding of the monoclonal antibody's properties. Often, ligands such as protein A, protein G, and protein L are employed. These proteins have a unique knack for binding to the Fc region of the antibody, allowing for efficient capture and purification. The process begins with the capture step. Here, the crude cell culture supernatant or clarified lysate, which houses our monoclonal antibodies, is loaded onto the affinity chromatography column. As if by magic, the antibodies bind to the ligand while other impurities are left to pass through the column. Next comes the washing step. The column is washed with a buffer, flushing out non-specifically bound impurities and contaminants. This step acts as a second line of defense, ensuring the purification of the monoclonal antibodies and removing any lingering impurities. Following the wash, the antibodies are ready to be eluted. This is achieved by altering the conditions of the chromatography system, such as the pH or ionic strength. This disruption frees the monoclonal antibodies from the ligand, allowing the purified antibodies to be collected. After elution, it's time to regenerate the column. This step involves washing the column under stricter conditions, stripping off any residual contaminants, and rejuvenating the ligand for future use. Quality control is paramount throughout this process. Samples are routinely collected at various stages and analyzed to confirm the purity and integrity of the monoclonal antibodies. Techniques such as SDS-PAGE, HPLC, and mass spectrometry are commonly employed for this purpose. Affinity chromatography is not confined to small-scale operations. It can be scaled up to accommodate larger volumes of crude feed material, making it a vital player in the industrial production of monoclonal antibodies. In essence, affinity chromatography is a cornerstone in the manufacturing of monoclonal antibodies. It provides a path to isolate these therapeutic molecules with high purity from complex mixtures, marking it as an irreplaceable step in the production of these vital healthcare tools.